So we're starting a new unit now that we've gotten through a beginning of proofs. We want to continue to look at some more things that we can talk about with different polygons. And now we're jumping out of triangles and into larger polygons. So let's get into today's first lesson. That'll get us ready for what we're going to be doing tomorrow. So make sure that tomorrow you're all set for this. In fact, we'll start class with a do now based on this information. So you got to know what's going on here. All right, so we've already talked about triangles. And we've seen that triangles, all the angles of a triangle sum to 180 degrees. We've known that. We've played with that for a while now. But what about other polygons? Well, a nice way to look at other polygons, and a lot of people know quadrilateral, it's got 4 sides. A lot of people know what that sum is going to be. But if you don't, suppose we just throw in a diagonal here, and now I've created 2 triangles. So that means there's 180 degrees in that triangle and 180 degrees in that triangle. So together, that's 360 degrees. So if you can't just flat out remember that a quadrilateral sums to 360 degrees for the angles, we can always break it up. Using that same idea, what about a pentagon? Now, I don't even remember what a pentagon's angles sum to. So I'm going to break it up as triangles again. And I'm going to do it so that all the triangles come from one vertex. So a pentagon, I get 3 triangles. So that's 3 triangles multiplying by 180. So if I do that in my calculator, let's see, bring my calculator on here. 3 times 180, that gives me 540. So a pentagon sums to 540 degrees. And I can keep doing that. Let's say I go up to a hexagon. Well, if I break the hexagon up, there's 1 triangle, 2 triangle, I get 4 triangles. So with a hexagon, I get 4 triangles, each one having 180 degrees. So that's 4 times 180 is 720. So a hexagon is 720 degrees. It'd be nice if we could do this without having to draw these triangles every single time. So let's look at how the numbers are relating here. Quadrilateral, 4 sides, I got 2 triangles. So 2 times 180. Pentagon, I got 5 sides, I got 3 triangles. Hexagon, I had 6 sides, I got 4 triangles. So how does the number of sides relate to the number of triangles? 4, 2, 5, 3, 6, 4. Think about that for a second. How many triangles would you get if I had 7 sides? Would be how many triangles? Now, if you notice that each time I'm 2 less, then you'd say, well, if you had 7 sides, that's 5 triangles. So using that idea, we can actually create a chart here. So a triangle, we said, has 3 sides. So that means it's going to be 180 degrees. That's basically 1 triangle times 180. Quadrilateral, 4 sides. So that's 2 times 180, which is 360. Pentagon, 5 sides. So we said that's 3 times 180. Okay, and I don't remember what that was all of a sudden. So that was 540. Hexagon had 6 sides. So 2 less than that is 4 times 180. And we said that was 720. So a septagon is 7 sides. So 2 less than that is 5. 5 times 180, 900 degrees for the sum of the angles. Octagon has 8 sides. So 2 less is 6 times 180, which gives me 1080 degrees. So n gone, if we have a number of n sides, we've said that the number of triangles we get is n minus 2. And I'm going to multiply that by 180. So that's a formula that we can use for any sized polygon. This brings us to our polygon sum theorem. Polygon sum theorem says the sum of the interior angles of a polygon with n sides is 180 times n minus 2. Okay, so n being however many number of sides it is, you can always use this formula. And again, if you can't remember the formula, break it up. So let's take a look at a couple examples. I want to solve for a here. Well, I know I've got 90 degrees here. It's a quadrilateral, so I know that's 360. So I can just do, right now I have 360 has to equal 76 plus 72 plus 90 plus a. So 76 plus 72 plus 90, and minus that from 360, I get that a is 122. Do the same thing for b. Notice I got two b's on this one. Okay. Let's see. Linear pairs are supplementary. So I get 110 here, and I get 112 here. So 110 plus 116 plus 112 plus another 110 plus 2 b's has to equal, and let's count my sides, 1, 2, 3, 4, 5, 6 sides. So that's 1080. And we can calculate that. 110 plus 116 plus 112 plus another 110, 180, 1080. That leaves me that 2b is 632. So b is 316. Okay, just double checking my arithmetic. Excellent. So that's the idea of doing these types of problems. With this problem here, let's see, vertical angles. So there's 44. That's 78. Let's see, I'm looking at this problem here. 180 minus 78, so I get 102 here. I can't sum those together because I got two different variables here, but I can find this missing angle here, the triangle. So 78 and 30 is 108. When I take that from the 180, I get 72, which actually should have been easier because it's now an exterior angle. So C is 108, 78 plus 30, which means that my quadrilateral is 44 plus 102 plus 108 plus D to equal 360. And doing the arithmetic there, I get that D equals 106. So why don't you try just playing around with the next three and see how you do on the next three, okay? So looking at E, I've got a pentagon, but it's got all angles equal. And we said the pentagon was 540 when I look up at the top. So 5 E's equals 540. That means E has to equal 108. This is a great way to figure out the angles of a regular anything, regular pentagon, regular hexagon. You can just sum it up and divide by the number of angles. Now, when I go to get F, I'm going to use it as a triangle. So 108, 108 on these. So that means, oops, each of these is 72. So I can easily calculate that. So 2 72s, take it from the 180, F is 36. Okay, looking at the next one that you did, let's see, I've got a pentagon here. So again, it takes 117 plus 108 plus 3 G's to give me to 540. Doing my calculations here, I get that 3G equals 315, so G is 105. Okay, to get H, well, let's see. Notice right there, those three angles come together to form a circle. So 108 plus 130, and if I take that out of 360, which is a circle, I get that that's 122. So now I've got 90 plus 122 plus 66 plus H has to equal 360. Okay, so a pretty simple way to handle these problems. There's basically just thinking your way through it. So I get that H is 82. And on to the last one. 1, 2, 3, 4, 5, 6. Hexagon. So 6 J's equals 1080. So I get that J is 180. Oops, did something wrong there. Oops, I looked at 8. 6 J's equals 720. That's better. So J equals 120. So that's 120. Parallel lines. Oh, hey, check this out. Remembering everything we know. I got parallel lines cut by a transversal. K and 38 are alternate interior angles. So that's 38 degrees. Now, that's talking about the interior angles. What about the exterior angles? Well, we learned that one exterior angle of a triangle is equal to the sum of the remote interior angles. Okay? Now, let's make the math easier. Let's assume this is an equilateral triangle. So each of these is 60. If that's true, then each of these is 120. And if I add that up, that's 3 120s. Whoops. Let's try writing that again so it actually makes sense. And 3 120s equals 360. What about if we try that same idea with a hexagon? Well, we said a hexagon, let's see the interior angles. Hexagon is 6, so that's 4 times 180. So, whoops, get rid of that. So that's 720. But there are 6 of them, so I'm going to divide that by 6. Notice what I did here to make my arithmetic. I'm going to call this x. That makes my arithmetic solid. So each angle is 120. And that's for all of these, since they're all going to be the same. Which means the exterior angle, because they're supplementary, is 60. And there are 6 of them. 1, 2, 3, 4, 5, 6. 6 times 60 equals 360 as well. So it turns out the exterior angle sum theorem says the sum of the exterior angles of a polygon is always 360 degrees. That's even easier than the interior because you get the same number every single time. How does that work? Well, let's look at this problem. I don't care about how many sides it has. I know that these exterior angles, 1, 2, 3, 4, 5, have to equal 360. I do need to know this last one. So that turns out to be 40 because of linear pairs. So now 40 plus 60 plus 84 plus 68 plus A has to equal 360 because they are the exterior angles. Okay, so that's 40 plus 60 plus 84 plus 68. So minus 360, that's going to give me A equals 108. Try the next one. Okay, so exterior angle, I need to get this one. So 180 minus the 68 is 112. That, and that are all the same. So 112 plus 43 plus 69 plus 3 B's should equal 360. So I've got, I've got 3 B's equals 136. Oops, let me double check my arithmetic. 112, 43, 69. And yep, that's looking like it's about right. Make sure I used the right numbers. Yep, looks like we're going to get a decimal or a fraction here. B is, let's simplify that to, if you got 45.3 degrees, or really I would leave it as 136 over 3. Okay, so that's our angle. Yes, you can get fractions. Yes, you can get decimals. Okay, but again, Doesn't matter how many angles there are, it's going to sum to 360. Now it's your turn to try. So you're going to go and do these problems. These are all on a Wiser Me. So work on these problems, see how you do. On the Wiser Me, you don't need degrees. You don't need to say x equals. You just need to put the number of what x actually is. Okay, so just type the number in and you're good to go. We'll review this on the morning and we'll move on. Okay, have a good evening.